Hello everyone, today I would like to talk about section 8.4. Um, uh, the title for the whole chapter 8 would be hypothesis testing for population proportion P. But especially for today, I'm trying to finish section 8.4 is about comparing proportions from two populations. So in section 8.4, you will learn how to conduct a hypothesis test comparing two population proportions. And how does the question look like? It's actually similar to 8.3, but this time they give us two groups at a time. Okay, two independent groups at a time. Like this example, in January 2014, the Gallup organization reported that 45% of Americans reported feeling pretty good about the amount of the money they had to spend. In January 2015, the Gallup reported that 49% of Americans felt this way. So both samples had the same sample size of 3,500. So it means right here, you should know that we have two sample size. So you can notate as N1 and N2. And can we conclude that the economic confidence has improved since 2014, or could this difference be due to chance variation during the sampling procedure? So it looks like they give us some percentage for 2 years. In 2014, 45% you can name as P1, and 49% as P2. So this percentage represent for population proportion of two different groups because we are having two different years. Okay, so you can notate as P1 would be 45% and P2 would be 49%. And sample size 1, which is N1, will be 3,500 and N2 will be 5,500. Okay, so for this one, it's not really what I'm looking for, because what I'm looking for is there will be more information, which is level of significance, which is alpha, for you to compare and conduct the test. And excuse me. And there will be more data for you to do. So for this example, it looks like you need to learn, this is good for you to look at this example and know how to analyze. Like, this is two different groups and two different P and two different N, okay? And the question is down here, they want to know if the economic confidence has improved since 2014 to 2015 or not. So let me see the next slide. Changes to the hypothesis. So P1, so that would be, so here's the explanation for that example, for the previous example. So P1 here represents for the proportion of Americans who felt pretty good about the amount of the money they had to spend in 2014. And P2 represent for the proportion of the Americans who felt pretty good about the amount of the money they had to spend in 2015, right? So here next, we are interested in the relationship between these two perimeters. So P1 and P2 represent for the perimeters, okay? And the estimators, which is you will learn later, not right now. Here you're focusing on the parameters. So P1 and P2, they straightforward, they talking about the entire population proportion. So in order to compare P1 and P2, so what do you do? So they really simply write down, in comparing two population proportion, the null hypothesis look like this: H naught colon P1 equal to P2. Or some people might write as H naught colon P1 minus P2. equal to 0. Doesn't matter. So to me, you set up like this is fine too. The alternative hypothesis is one of these three possibilities. So below will be A, B, C. The first case is happen for the alternate hypothesis will be HA colon P1 not equal to P2. This is represent for two-tailed tests, right? So you compute regularly later, or I will go to step by step and more computation so that you can see it. We run step quants for this. And for part B, the alternate hypothesis will be P1 greater than P2. So this is, they might give you some hint. For example, like improving or more than or longer or bigger than, stuff like that. And for come back to case A, the question may be like unknown, a difference between P1 and P2, will be any change, and so on. And part C, for case C, the alternate hypothesis, colon, HA colon, P1 less than P2. So this case is the hint might be some wording opposite with case A, right? So like, for example, shorter, smaller, decrease, less than, stuff like that. And here is a slide 5, is more summarized for you to look at. So when you are writing the hypothesis, one-sided or two-sided test, so here you notice we are talking about population proportion, okay? So again, right here you notice for two-sided, you got 3 cases. Okay, so two-sided, one-sided left, one-sided right, and here is what you need to read, which is similar to previous slide, but in table form. Changes to the test statistics. So here is another, like a bit, go into more details. So the test statistic has the same general form. We all have to looking for Z. So the Z value as you are looking for in a part 2, a part 1, a part 3. So Z, but we have to use different formula for Z for each section. For this Z, because you are talking about 2 population proportion. So you, for the estimator here, I told you earlier, the estimator here is the value that is help us estimating the perimeter, okay? And the perimeter is P. In this case, we're talking about P1, P2. P1, P2 represent for perimeters. And for this estimator happen when? This happened when in the story they give us more specific number, okay, about the population so that we can using those information to estimating the perimeter, which is P1, P2. So an estimator in this case would be P hat 1 minus P hat 2. So that's how you read it. P hat represent for sample population proportion, okay? So you would take P hat 1 minus P hat 2, you will put that right at the estimator position right there, minus the null value. And the null value, you will see that the null value mostly will be 0, right? And SE will be, we will compute by using the formula. And again, the easiest steps, the easiest way is we should take advantage of StatQuant to do it. And later I will have a slide about StatQuant, how to run this for you to look at, and you can practice on those. Estimator P hat 1 minus P hat 2, because we are estimating P1 minus P2. The null hypothesis is 0 because our null hypothesis is look like this, like I explained before. So P naught for the null hypothesis is P naught equal to P2 or you can put that as the equation like this. P1 minus P2 equal to 0. So let me go a bit details here. So compute by hand is very like complicated. So I suggest again, you can using StatQuench is the best, and then TI-84. It's up to you. This way is compute by hand. It's showing you how to go step by steps in more detail. But when you're doing on your task, on your work, I don't expect you to do by hands because this is, I am flexible. So I'm okay with doing by hands. StatQuench or TI-84 is up to you. So if you're doing by hand, but look at this process. So in order to compute standard error, you have this formula above here on your left corner. So SA will be equal to square root of everything. Square root of P hat times 1 minus P hat. Some people can replace this parentheses right there will be Q hat. So if you got value for P hat, you can find this easily. And where you got this? This P hat represents for sample proportion. Time with 1 divided by n subscript 1 plus 1 divided by n subscript 2. N subscript 1 is sample size in sample 1. N subscript 2 is a sample size in sample 2. So the P hat, how you can compute the P hat? Look like the P hat, we need to compute both sample size, okay? So you will take the number of the success in sample size number 1. You add with the number of the success in sample size number 2. Everything you divided by the total of the sample size, which is for both, which is N1 plus N2. That is your P hat for the standard error. N1, N2, there will be difference or might be it's the same. So you have to be careful to plug that in. For P hat 1, the number of success in sample 1, how do you compute? So you compute by taking the number of the success in the sample 1 divided by n subscript 1. Okay, if you compute separately, it will be like this. But if you compute together, I suggest that you compute together so that you don't confusing why is P hat 1, P hat 2 right there is too much. So you just focusing on P hat right there. You find the number of success in sample 1, you write it here. You add with the number of success in sample 2, you write it here. Divided by that's 2 add together. That's it, you're done. So if question specifically asking about P hat 1, this is what you do. This is the formula for you to do. And P hat 2, this is the formula too. So they say in practice, the test statistic and corresponding p-value are computed using the appropriate technologies. So all of us suggest that you run technologies, so you should not compute by hand because it takes too long. So right here, for checking conditions, actually, as you are already understand input 1, input 2, input 3, you will see that the conditions they are setting up for us to test, like I told you, most of the time, and to me, when I write a test, I will all the time give it to you, the problem already passed this condition. But some question might asking you to checking for this condition, so please do so. And what do you need to check? Number 1, large sample size. Is it enough large to pass the condition so that you can move on? By checking what? You take N1 multiply P hat. Great. You check that if it is greater or equal to 10. And N1 multiply with 1 minus P hat. Another word, N1 and subscript 1 times Q hat. Check that if it's greater or equal to 10. And you have to do the same thing with the sample 2. And like I said, all the time will be greater than this. So personally, when I teach you, when you're doing the test like this, I don't force you to write all this condition because I'm not asking for it. But it's good for you to know that, okay, you should check the conditions before you keep moving to phi Z and SA and stuff, okay? And the reason I'm saying like that, the reason I'm saying I'm not forcing you to checking the condition, because when you're using StatQuant, they don't check it. Okay, you just enter all the given data in and just run it. Then you got the what you need. You got what I need. So which is the p-value and the z-value. Okay, so that's the reason why I'm keep saying that you don't have to check the conditions, but actually like you should know it. Okay. So option number two, condition number two, random samples. If we are not told explicitly that the sample was randomly drawn, we might have to assume this condition is satisfied. So that is one of the reason, right? So that is all the time this will be random sample, and they have it large enough for us to do the work. Independent sample, and again, most of the time we should make sure that every single event, every single observations have to be independent, which is they not really affect of each other. Independence within sample, so the same thing. The observation within each sample must be independent of one another. Example 2. Example 2, Gallup poll on consumer confidence. So this is, let me see. So look like this example is really like the first example at the beginning we talked about. So let me go back slide 3 so that you can see it. So let's take a minute to look it over. It's kind of the same, right? So, but what is the difference? So right here, they're talking about P1, P2, the population proportion, the perimeter, right? But go back to slide number 10. So let's read this all together. So researchers from the Gallup poll interviewed 2 random samples. Both samples, one taken in January 2014 and one taken in January 2015. So both had 3,500 people. It means you are having N1 is 3,500 and N2 is 3,500. In January 2014, about 1,575 respondents said that they felt pretty good about the amount of money they had to spend. So it's look like you see the data right here that I just go through, 1,575. This will be it will be the number of the success in sample size 1, which is in 2014. So this is the number of the success right there. So your p hat will be 1575 divided by 3500. That is your p hat 1. Okay, so if you want to compute, if you look for p hat 1, then that would be the value. So let me move on. In January 2015, about 1,715 respondents felt this way. So again, so this value right here is 1715 is the number of the success in 2015. So to find p hat 2, you take 1715 divided by 3,500 right there. And remember, 2014, they are having 3,500 people. 2015, they having another 3,500 people. So, so when you conduct this hypothesis test, you have another faster way is what? You can combine, right? You combine p hat like this. Let me see. You combine like this. You see that? You found this p hat right there. So that you compute this, and then you plug back in. So let me see what the question. Can we conclude that the economic confidence has improved since 2014? So look at this question. It's very clear, correct? So the key word in here that we can see is the word has improved. The hint it has improved, telling you the alternate hypothesis test will be greater than. And the level of the significance is 5% or 0.05. So let me move on to the next slide. Example 3, consumer confidence. The data is summarized in the table below. In 2014, they are having the number of the success is 1575. That's this number are the people they are feeling pretty good. And so that you can imply the number of the people did not feel pretty good would be 1925. Similarly with 2014, they given us the number of the success is 1715. So we can imply by taking 3,500 minus 1715 to have 1785. So let's see the total. Total of two groups will be 7,000. Now you're gonna learn how to conduct. So this is the step, how you can conduct the hypothesis test for two population proportion. So let's assume P1 will be the proportion in 2014 who felt pretty good. And let P2 is the proportion in 2015 who felt pretty good. So step 1, the hypothesize. You want to set up the null hypothesis. All the time there's no hypothesis, not change. When you're comparing two population proportion. So we have H naught colon P1 equal to P2. So this, you don't have to change to anything. You should not put in any numbers in here, okay? But the alternate hypothesis in this case, this is not right to me. This should be greater than, because the hint is has improved, right? So let me see the next slide if they makes any mistakes. So second condition right here, again, you check up, you testing, is it enough? Is it independent, random, and large enough to do it? When you're doing by hand, you have to, you should go over the steps. So if you run StatQuant, you don't have to. So let's look at StatQuant. They compute quickly. You go to stat, and then you go to proportion stat, and then you click to sample, and then you click with summary. It's similar to what I showed you previously in section 8.3 or 8.2. Okay, so I think I make a small mistake. So has improved is maybe my interpretation a bit confusing right here. So has improved to me is greater than, but it looked like okay. So I accept that I'm wrong. I mislead you right there. So I would like to take it back. So I would like to say has improved. Proof will be less than the left tail. Okay. So look at right here. Let me see. They go to step by step as we have. Then you put in the number of success. The total of the observance, the number of success, and the total of observance right there. And we are You see that they put in here 0 right there, because when you put aside P1 minus P2 equal to 0, you put there. And alternate hypothesis would be P1 minus P2 less than 0, right? And then you click compute, you got this value. You got Z stat is -3.3, and P value will be very small. Okay. Okay, so let's do another example. So since it's less than, so we reject the null hypothesis. So we conclude that the consumer confidence has increased. So that is a bit confused to me. That's why I interpret the word has improved should be has improved. I know it, because it's the questions. So we are wondering if it's improved or not. Let me go back, because I would like to be clear right here. Can we conclude that the economic confidence has improved? Okay, so that means you are unsure that is improved or not improved. Okay, it's been a long time. So we have that. So let's do another example. Let me see, right here, they're talking about using TI-84. For those who are using TI-84, you can follow these steps, okay? Here is another example. A student is interested in determining if there are gender differences in texting while driving. She collects data from a random sample of 80 men and 60 women. So this is look like the sample size for each. We have two groups, men and women, and one will be 80 and two will be 60. So of the 80 men, 38 reported they had texted while driving. So it means 38 would be the number of the success, right? Divided by 80, you will have P hat 1. Of the 60 women, we have 27 reported they had texted while driving. So in order to find P hat 2, which is the sample proportion, you got 27 divided by 60, you got a value, or you can combine both by, if you're finding Z, applying the formula that we are having, you can take 38 plus 27 divided by 80 plus 60. You got a value for P hat. If you compute by hands. If you don't compute by hands, you can use StatCrunch, enter the value like we did, then you run and then you'll be okay. So assume the sample were random and independent. Can the student conclude that the proportion of men and women who text while driving are different? So here, right here, the keywords to me will be not equal to, will be two tests. And they want us to use the level of significance of 0.05. Here they summarize in this table. Okay. And the steps they're listing out, P1, P2. Step 1, hypothesize. H0 will be all the time like this. And if you take P1 minus P2 equal to 0, will be equal to 0. Okay, and the alternate hypothesis will be P1 not equal to P2. Or if you run StatCrunch, what are you gonna do? You're gonna have P1 minus P2 not equal to 0. That's what you need to put on in your StatCrunch. So here is the step 2. When you compute, when you're doing by hands, you're testing for it. And again, this is satisfying. So when you run StatCrunch, look at this. Sample 1, the number of success is 38. The number of the observance will be 80. The sample 2 is the number of success is 27. And the number of the observance will be 60. And make sure you check this box, okay? The next step, you will enter the number 0 right there, or maybe they already set up defaults. But right here, you just, change for the sign. So right here is not equal to. You see that they put P1 minus P2? Here's not equal to 0. And you run compute. When you run compute, you have in the following value. The P value kind of very large, 0.7 691. Wow, it's very large compared to alpha. Alpha is only 0.05%, and this is look like it's almost 77%. So we do not reject the null hypothesis, right? So interpret this: since our p-value is large, greater than the R significant level, we will not reject the null hypothesis. We cannot conclude that there is a difference in the proportion of men and women who text while driving. I'm sorry for any mislead or confusing in previous example because of the bit wording in the questions. But I hope you like this video and keep doing your work, keep doing your hard work. Okay, see you next time.